Can you spot the idea that unlocks each one? Differentiation and normals on a curve. Circle geometry, tangent and normal lines. Geometric progressions linked across two series. Functions, inverses, and graph transformations. Trigonometric identities and equations. Sectors, triangles, and a shaded region. Area beneath a curve, definite integration. A disguised quadratic in x cubed. Completing the square and no real roots. Binomial coefficients. Question 1. Equation of a curve from dy by dx. Pure Mathematics 1, May-June 2023. The gradient of a curve is dy by dx equals 4 over x minus 3 cubed, 4x greater than 3. The curve passes through the point 4, 5. Find the equation of the curve. Now let's work through the solution step by step. Part A. Integrate to recover y. Rewrite the gradient in power form. Integrate both sides with respect to x. Apply the power rule, add 1 to the power, then divide. Simplify and add the constant of integration. Raise the power from -3 to -2, then divide by -2. That's the power rule. Now substitute the given point to find c. Part B. Use the point 4, 5 to find c. Substitute x equals 4 and y equals 5. Solve for c. Write the equation of the curve. So the equation of the curve is y equals 7 minus 2 over x minus 3 squared, 4x greater than 3. And that completes question 1. Question 2. Binomial coefficients. Pure Mathematics 1, May-June 2023. The coefficient of x to the 4 in x plus a to the 6 is p. The coefficient of x squared in ax plus 3 to the 4 is q. Given that p plus q equals 276, find the possible values of a. Now let's work through the solution step by step. Before we start, recall the binomial expansion formula. The general term is t sub r plus 1. To find a specific coefficient, set the power of x equal to k. We'll keep the general term on the right as a reminder. Part A. Find the coefficient of x to the 4 in x plus a to the 6. In x plus a to the 6, the x to the 4 term uses r equals 2. 15 a squared is the coefficient, so p equals 15 a squared. Now find q from the second expansion. Part B. Find the coefficient of x squared in ax plus 3 to the 4. In ax plus 3 to the 4, the x squared term uses r equals 2. 6 times 9 a squared gives q equals 54 a squared. Finally, use p plus q equals 276. Part C. Solve p plus q equals 276. Add 15 a squared and 54 a squared. Divide both sides by 69. Take square roots. So a equals 2 or a equals -2. And that completes question 2. Question 3. Completing the square. Pure Mathematics 1, May-June 2023. Part A. Express 4x squared minus 24x plus p in the form ax plus b squared plus c, where a and b are integers and c is in terms of p. Now let's work through the solution step by step. Complete the square. Factor out 4, so a equals 2 inside the bracket. Complete the square, add and subtract 9. Expand and simplify. The form is 2x minus 6 squared plus p minus 36. So a equals 2, b equals -6, and c equals p minus 36. Part B. Hence find the values of p for which 4x squared minus 24x plus p equals 0 has no real roots. Use the completed square form from Part A. Now let's work through the solution step by step. Use the completed square form to decide when there are no real roots. 2x minus 6 squared is never negative. No real roots means the minimum value is above 0. So p minus 36 must be greater than 0. Therefore p is greater than 36. The equation has no real roots when p is greater than 36. And that completes question 3. Question 4. Disguised quadratic. Pure Mathematics 1, May-June 2023. Solve the equation 8x to the 6 plus 215x cubed minus 27 equals 0. Part A. Substitute u equals x cubed and solve for u. Now let's work through the solution step by step. Let u equal x cubed to reduce this to a quadratic in u. Let u equal x cubed. Factor the quadratic in u. So u is 1/8 or u is negative 27. Solve the equation 8x to the 6 plus 215x cubed minus 27 equals 0. Part B. Hence find the values of x. Now let's work through the solution step by step. Back substitute x cubed equals u and take cube roots. When x cubed equals 1/8, x equals 1/2. When x cubed equals negative 27, x equals negative 3. The solutions are 1/2 and negative 3. So x equals 1/2 or x equals negative 3. And that completes question 4. Question 5. Area under a curve. Pure Mathematics 1, May-June 2023. The curve y equals 10 root x minus 5 over 2 times x to the 3 halves, 4x greater than 0, meets the x-axis at 0, 0 and 4, 0. Find the area of the shaded region between the curve and the x-axis. Now let's work through the solution step by step. Shaded area means a definite integral from 0 to 4. Sketch the curve. The shaded region sits between x equals 0 and x equals 4. Right area equals the integral from 0 to 4. Integrate the first term, 10 root x. Integrate the second term, minus 5 over 2 times x to the 3 halves. Substitute x equals 4. 4 to the 3 halves is 8. Simplify to 64 over 3. Remember the power rule, add 1 to the power, then divide by the new power. The area is 64 over 3. And that completes question 5. Question 6. Sector and shaded region. Pure Mathematics 1, May-June 2023. Sector OAB has center O, angle AOB equals theta radians. Point P lies on OB with OP equals AP equals x. Part A. Show the arc length AB is 2x theta cos theta. Now let's work through the solution step by step. Triangle OAP is isosceles. Use that to find the radius OA. OP and AP both equal x, angle at O is theta. OP equals AP equals x, so triangle OAP is isosceles. Drop a perpendicular to find OA equals 2x cos theta. Arc length equals radius times angle. So arc AB is 2x theta cos theta. That proves part A. Sector OAB has center O, angle AOB equals theta radians. Point P lies on OB with OP equals AP equals x. Part B. Find the area of the shaded region APB. Now let's work through the solution step by step. Shaded area equals sector minus triangle OAP. Redraw the diagram. Sector OAB, half r squared theta. Substitute r equals 2x cos theta. Triangle OAP, half x squared sine 2 theta. Shaded area equals sector minus triangle. That completes question 6. Question 7. Trigonometric identities. Pure Mathematics 1, May-June 2023. Part 1. Expand cosine t plus sine t squared, and solve cosine t plus sine t squared equals 1, 4t between 0 and pi. Now let's work through the solution step by step. Expand the square, then use a trig identity. Expand, 1 plus 2 sine t cosine t equals 1. So sine t cosine t equals 0. Sin t equals 0 gives t equals 0 or pi. Cos t equals 0 gives t equals pi over 2. All solutions, 0, pi over 2, and pi. Solutions 0, pi over 2, and pi. Part 2. Hence verify cosine t plus sine t equals 1 has only solutions 0 and pi over 2. Now let's work through the solution step by step. Squaring can add extra solutions. Test each value by substitution. Test t equals 0, 1 plus 0 equals 1. Good. Test t equals pi over 2, 0 plus 1 equals 1. Good. Test t equals pi, minus 1 plus 0 is not 1. Reject pi. So only 0 and pi over 2 work. Only 0 and pi over 2 work. Part B. Prove sine t over cosine t plus sine t, plus 1 minus cosine t over cosine t minus sine t, equals cosine t plus sine t minus 1, over 1 minus 2 sine squared t. Now let's work through the solution step by step. Put both fractions over the same denominator. Common denominator is cosine t plus sine t times cosine t minus sine t. That equals 1 minus 2 sin squared t. Expand the numerator. It simplifies to cosine t plus sine t minus 1. Write as one fraction over the common denominator. So the left side equals the right side. Identity proved. Part C. Solve the left side from Part B equals 2 times cosine t plus sine t minus 1, 4t between 0 and pi. Now let's work through the solution step by step. Substitute the identity from Part B, then factor. Replace the left side using Part B. Factor out cosine t plus sine t minus 1. Case 1. Cosine t plus sine t minus 1 equals 0 gives 0 and pi over 2. Case 2. 1 over 1 minus 2 sin squared t minus 2 equals 0. That gives sin squared t equals 1/4, so t is pi over 6 or 5 pi over 6. T equals 0, pi over 6, pi over 2, or 5 pi over 6. Question 7 complete. Question 8. Functions and inverses. Pure Mathematics 1, May-June 2023. f of x equals 3 plus 2 sine of 1/4 x, 4x between 0 and 2 pi. Part A. Sketch y equals f inverse of x. Now let's work through the solution step by step. To sketch the inverse, reflect f in the line y equals x. Draw f, the line y equals x, then reflect f to get the inverse. f of x equals 3 plus 2 sine 1/4 x. Part B. Find f inverse of x. Now let's work through the solution step by step. Swap y and x, then make x the subject. Start with y equals 3 plus 2 sine x over 4. So sine x over 4 equals y minus 3 over 2. Take inverse sine and multiply by 4. F inverse of x with domain 3 to 5. G of x equals 3 plus 2 sine 1/4 x, 4x from minus 2 pi to 2 pi. Part C. Does G have an inverse? Now let's work through the solution step by step. An inverse exists only if G is 1 to 1. When x goes from minus 2 pi to 2 pi, x over 4 goes from minus pi over 2 to pi over 2. Sine is increasing on that interval. So G is 1 to 1 and does have an inverse. Yes, G has an inverse. f of x equals 3 plus 2 sine 1/4 x. Part D. Describe 3 transformations mapping y equals sine x to y equals f of x. Now let's work through the solution step by step. Start from y equals sine x and apply 3 transformations in order. First stretch parallel to the x-axis, factor 4. Then stretch parallel to the y-axis, factor 2. Finally translate up by 3. Stretch vertically before you translate upward. Question 8 complete. Question 9. Geometric progression. Pure Mathematics 1, May-June 2023. A geometric progression has second term 16 and sum to infinity 100. Part A. Find the 2 possible values of the first term. Now let's work through the solution step by step. Write AR equals 16 and sum to infinity equals 100. Second term, A times R equals 16. Sum to infinity, A over 1 minus r equals 100. Substitute a equals 16 over r into the sum formula. Solve the quadratic. R is 1/5 or 4/5. So the first term is 80 or 20. First term 80 or 20. A geometric progression has second term 16 and sum to infinity 100. Part B. Show the nth term of one GP equals 4 to the n minus 2 times the nth term of the other. Now let's work through the solution step by step. Write the nth term of each progression separately. First GP, un equals 20 times 4/5 to the n minus 1. Second GP, vn equals 80 times 1/5 to the n minus 1. Divide un by vn. The ratio simplifies to 4 to the n minus 2. So un equals 4 to the n minus 2 times vn. So un equals 4 to the n minus 2 times vn. Question 9 complete. Question 10. Circle, tangent and normal. Pure Mathematics 1, May-June 2023. The circle x minus a squared plus y minus 3 squared equals 20. The line y equals 1/2 x plus 6 is a tangent at point P. Part A. Show a equals 4 is possible, and find the other value of a. Now let's work through the solution step by step. Tangent means the perpendicular distance from center C to the line equals the radius r. Here the line touches at P. Mark the radius from C to P. This distance must equal root 20. Center is a comma 3. Radius is root 20. Rewrite the line as x minus 2y plus 12 equals 0. Distance CP equals r. So absolute a plus 6 over root 5 equals 2 root 5. So a is 4 or minus 16. A equals 4 or minus 16. The circle with a equals 4. The line y equals 1/2 x plus 6 is a tangent. Part B. 4a equals 4, find the normal to the circle at P. Part B. 4a equals 4, find the normal to the circle at P. Now let's work through the solution step by step. The normal passes through C and P. It is perpendicular to the tangent. Its gradient is minus 2. Center is 4,3. Tangent gradient is 1/2. Normal gradient is minus 2, negative reciprocal. Line through 4,3 with gradient minus 2. Normal equation, y equals minus 2x plus 11. Normal is y equals minus 2x plus 11. The circle with a equals 4. Part C. Find the two tangents parallel to that normal. Part C. Find the two tangents parallel to that normal. Now let's work through the solution step by step. Draw both tangents with gradient minus 2. Each must be distance r from the center. Write y equals minus 2x plus c. Distance from center 4,3 to this line must equal the radius. So c is 1 or 21. The two tangents are y equals minus 2x plus 1 and plus 21. Tangents y equals minus 2x plus 1 and minus 2x plus 21. Question 10 complete. Question 11. Differentiation and normal. Pure Mathematics 1, May-June 2023. Y equals k times the square root of 4x plus 1 minus x plus 5, where k is a positive constant. Part A. Find dy by dx. Now let's work through the solution step by step. The square root needs the chain rule. Rewrite y using power form. Differentiate the square root. Bring down the power, multiply by 4. Differentiate minus x plus 5 gives minus 1. That is dy by dx. Y equals k root 4x plus 1 minus x plus 5. Part B. Find the x-coordinate of the stationary point in terms of k. Now let's work through the solution step by step. At a stationary point, dy by dx equals 0. On the graph, the tangent is horizontal where dy by dx equals 0. Set 2k over root 4x plus 1 minus 1 equal to 0. Rearrange, Root 4x plus 1 equals 2k. Square both sides. X equals k squared minus 1/4. Stationary point at x equals k squared minus 1/4. Y equals k root 4x plus 1 minus x plus 5. Part C. 4k equals 10.5. Find the normal where the tangent makes angle arctan 2 with the positive x-axis. Part C. 4k equals 10.5. Find the normal where the tangent makes angle arctan 2 with the positive x-axis. Now let's work through the solution step by step. Arctan 2 means the tangent gradient is 2. The tangent line has gradient 2. That is what arctan 2 means. Tangent gradient is 2. Set dy by dx equal to 2 with k equals 10.5. Solve for x equals 12. Find y at that point. Y equals 66.5. Normal gradient is minus 1/2. Normal equation, y equals minus 1/2 x plus 72.5. Normal is y equals minus 1/2 x plus 72.5. Question 11 complete.